So for Chapter 9, Section 4, we are going to be getting into graphing radical functions, and we're going to be using some of the same things that we have talked about with graphing quadratics in the previous sections. A radical function would be when instead of having something raised to an exponent, you have like a root symbol in your problem. So for example, we've seen a lot of these types of graphs. These would be that quadratic form. If I wanted to get rid of something squared, I would do the square root of that. And so that's what a radical would be. So instead, we're going to see things that have this type of symbol involved, where you have kind of like a division bar, but it has this little tail kind of sitting in the front. So this is called the square root, or you'll hear me call it like a radical function instead of saying square root all the time, because we also have things like the cubed root, the fourth root, the fifth root, and so on. And so radical is just a way that we can kind of talk about all of them together. Now, in the past, we've seen these square root, or these quadratic functions, so like y equals x squared. You know, it's that parabola shape, so it looks kind of like a U. If I were to look at the square root function, there is technically a positive and a negative side to that. Because if you square root, let's say you're square rooting 36. The square root is looking for the number times itself. That would get you to 36. So I have two options. I could either do 6 times 6, or I could do -6 times -6. Both of those would work, which is why you'll see this plus minus sign sitting in front of a square root sign, because there could be the positive or the negative answer. So when we talk about the graph, it still kind of has like that U shape, but it's almost on its side. So it's like they took that parabola and they flipped it onto its side. Now I'm going to tell you guys that we are probably only going to be dealing with this top portion of the graph. We're probably not going to worry so much about the bottom. Just because when you're dealing with that, that's something that we haven't talked much about with the negative side of things. So we'll probably, when we graph our radicals today, only be graphing like the top half of those square roots. Now another graph that you'll see a little bit of is like the cubed function. So we have y equals x to the third power. This one looks a little bit different than your quadratic does, because if you notice, you've got your vertex at 0, 0, but this half kind of goes up and this half goes down. So it almost is kind of like an S shape, but it's really stretched out. And so it's going to have kind of this curved nature to it. So if I'm looking at the cubed root graph, the same thing happens. I still have my vertex there at 0, 0. We've got this piece that kind of goes up, and then we've got this piece that kind of goes down and to the left. So it's still resembling that cubed function that we had over here on the left. It's just this one's now kind of on its side, and it's kind of pointing off into different directions. So I want to review with you guys when we talked about movements of these quadratic graphs in the previous section. So section 3, remember we talked about all these different ways that we can transform a quadratic function by moving it left, right, up, down. We can stretch it, we can compress it, all those things. We had our equations written in this form. That was that vertex form that we had talked about, where A was telling us what the stretch was, so whether it was going to be stretched or compressed, if it was going to be, really skinny or really, really wide, if it was going to open up or open down, so if it's positive or negative. And then H and K, that tells us what the movement is as far as if it's moving left or right, up or down. So remember H, the horizontal movement, that means that you're going left or right. Where K is the vertical movement, which means it's going up or down. So I want to go over a couple examples with you so you can see how you can still do some of these same things with those quadratics, but now how we can apply it to these other types of graphs that I've talked about also. So this is what we saw in section 3. Where you had something written in that vertex form. Your 2 is in the A spot, your 3 is in the H, your 4 is in the K. So if I'm talking about just looking at the equation right now and figuring out what its movement is, the 3 and the 4, that's your HK, that's your vertex. So the 3 is positive, so remember we have to think opposite. So that means that we actually went to the left 3. And the +4 means that we went up 4. That 2 in the very front is your stretch. So that means that when you go left and right 1 from your vertex, you go up 2 points instead of the traditional 1. So again, remember when we graph these in section 3, we started by graphing the vertex first. So from 0, 0, we went 3 to the left and 4 up. And that's our vertex. And then we go left 1, right 1 on either side of the vertex, but you go up 2 because of that stretch factor. So this is what you did in the last section, section 3. Okay, so that should be review from what we had done in section 3, because now what we're going to do is take this same idea of these movements here and we're going to apply it to these other types of graphs. So let's take a look at this one. We've got a square root graph. Now it's very similar to what we saw up above. Instead of having parentheses around that x plus 3 and it being raised to the second power, it has that square root sign. The movements are not going to be any different than that last one was, though, because we have the same types of numbers in the same spot. We still have 2 is our A, 3 is our H, 4 is our K. So 3, it's plus 3, so think opposite. So that means it went left 3. Plus 4 means that it went 4 up. And that 2 is a stretch. So let me show you how you're going to graph this one, because now instead of having that parabola shape, we're dealing with the square root function. So I'm going to go left 3 and up 4, just like I did with my equation up above. I went the same directions for that vertex, but instead of you kind of making that U shape, I don't want to see this happen. We have to have that square root shape, which looks like this. Remember I said we're probably only going to graph the top half. So you're only going to go over to the right one, and then you're going to go up 2 because of your stretch and draw a point. So it's very similar to what we did with the quadratic, but instead of going like up, you know, on that quadratic like we would for that U shape, this one is going to go up but also to the right. So it's going to have, remember, it's that parabola on its side, so we've kind of flipped it over. And that's your graph, like roughly sketching that out. Now, of course, there's lots of other points out there that we just haven't talked about, but this is just using those same movement directions and using the same technique that we did yesterday in order to graph these new types of functions. Now, if you look at the next example I have here, it looks pretty similar to what we just did. There's one minor change here. This time your A has that negative sign in front of it instead of a positive 2. So I'm still moving the same direction as far as my 3 and my 4 are concerned. So the 3 plus 3 is still saying that we're moving to the left 3. And the plus 4 is still saying that we went up 4. But that negative 2, that's your stretch. But that's going to flip this graph upside down because it's negative, so it's going to reflect it. So when I go to graph this one, I'm still going to go left 3, up 4, and draw my point there. And then that stretch is negative 2. So I'm going to go over to the right, but instead of going up 2 like I did on the previous one, I'm going to go down 2 because it's negative. And so this graph is going to go like this. So on the next page here, there are 4 practice problems. There's these 2, and there's these 2. I want you guys to go ahead and give them a try. Start with these 2, and then we'll go through the next 2 as well. So if you want to try to do all 4, you can. If you want to try to just do 2 and then do 2 after that, that's fine. But what I would suggest is that you pause the video, you try to do these on your own, and then when you're ready to see what they should look like, you resume watching. So for this first one, if it's helpful for you to kind of write A, H, and K underneath your numbers, I would do that. Now both of these are similar in that they have the same numbers. It's just this one here on the left is going to be a traditional quadratic, so it's going to have that U shape, where this one has the root symbol, so it's going to look something like that. So for the one on the left, your -1 tells you that you went right 1, and that -2 on the end means you went down 2 for your vertex. 3 is your stretch, so you're going to go left 1 and right 1 because this is a traditional quadratic. So you're going to go left 1 and up 3, and you're going to go right 1 and up 3, and then draw in that parabola. Now the movements are all going to be the same for this side. You're still going to go right 1, down 2 for your vertex. Your stretch is still 3, so you're going to go right 1, up 3 and draw that point. But instead this is that square root function. So it should kind of go up and then out to the right. For the last two here, these ones have the 3's involved as an exponent. So we've got it raised to the 3rd power. We've got the cube root. So at the start of class, I did talk about those right here. So this is the type of graph that we're dealing with for these last two. So if you weren't sure how to graph that shape, this is what they should have looked like for both of them. So as far as the movement goes for the vertex, it's the same as those two up above. We have the 3, the 1, the 2. So like moving the vertex is the same, and your stretch is going to be the same. It's just going to have a different shape to it now because of that 3 that they threw into the problem. So we're still going to go left 1, down 2 for our vertex. For this original one on the left, your stretch is still 3, so you're going to go right 1, up 3. And you're going to go left 1, down 3, because you have to make that kind of S shape. So it's going to go up through that point and down through the point on the left. For the root function, again, you're going to go right 1, down 2 for your vertex. And it's going to look like you're doing the same movement because you're going to go right 1, up 3, and left 1, down 3. So some of you are probably looking at this and saying, well, it looks exactly the same. And it does right now, but remember when you connect your points here, instead of it going up, it needs to kind of curve and go to the right, and this side's going to curve and go to the left. So it's going to be a little bit different in how you pull those lines away from those points that you go through.